Good evening, Internet. I am Matt Buyak, and in this video, we'll be taking a look at the 19th problem from the Project Euler Problem Archive. So this question asks us to find the number of months in the 20th century in which the first of the month was a Sunday. And it clarifies that by 20th century, it means starting on the 1st of January 1901 and going to the 31st of December in the year 2000. You'll note that the primary complexity in this problem comes from the fact that not every month has the same number of days and not every year has the same number of days. That is, a leap year will have one extra day. And it gives the rules here for the number of days in a given month and which years correspond to leap years. So keeping that in mind, let's get into it. So as usual, we will copy our template directory to make our problem directory. And we'll open our main.cpp. So the rough outline of our approach to solving this problem is going to be quite simple. So we'll need to keep track of the current day, month, and year. So we'll say day, month, year. And to clarify, this day here is going to be the day of the week. And so before we begin, we're going to need to know what day of the week was Tuesday. Well, I just gave it away. January 1st, 1901, which I've already Googled, and it's a Tuesday. And so the convention that we will use is that Sunday will be the day number 0 of the week, Monday day number 1, and Tuesday day number 2. So we'll start off by saying day equals 2, and that is a Tuesday. Okay, so now we're going to have our loops. We're going to say the year is going to go from 1901 to 2001. That is just less than 2001. And we're going to increment the year at the end of each year. We'll also iterate over the months. So we'll say, starting with month equals 0, and month is less than 12. Similarly to the day of the week, we will use 0 for January, 1 for February, 2 for March, etc. Okay, and so the rough outline of how we're going to solve this is just going to be to say, if day equals 0, then we'll need a counter. So we'll say count starts at 0. And if recall, day equals 0 means that it is a Sunday. So we'll say if it is Sunday, then we'll do plus count. And then we just need to increase day by the number of days in the current month. And so that depends on two factors. First of all, the month that we're currently in, and then the whether or not the current year is a leap year. And so let's just put together a quick table here. Say const uint32t days in month, and that's going to have 12 elements, and it's going to be 31 for January, 30 in February, 28 in February, 31 in March, 30 in April, 31 in May, 30 in June, 31 in July, 31 in August. And one thing you'll notice is I've marked February as being 28 days. Obviously, that won't be the case for a leap year, but for most years that will be the case. Okay, 30 in September, 31 in October, 30 in November, and 31 in December. All right, so now we can say so we'll need to check to see whether or not the current month is February. If it's not February and it's not a leap year, then we can just look up our number in the table here. And so in order to check whether or not our current year is a leap year, let's go back to the rules that they gave us. So it says a leap year is any year that's divisible by 4, but not on a century unless it's divisible by 400. And most of this we can actually ignore because the only century within our range here is going to be February of the year 2000. And 2000 is divisible by 400, and so the usual rule applies. That is, we only have to check if the year is divisible by 4 because our range is limited to 1901 to 2000. So that check is adequate. Okay, so we can just say here, if month equals 1, and let's make a note here, month equals 1 implies February. So if month equals 1 and, let's see, year and 3 equals 0. So this is just a little bitwise logic. So this 3, you'll recall 3 in binary is just 1, 1. And so this is masking off the bottom 2 bits. And any year that's divisible by 4, those will be equal to 0. So this is just equivalent to saying if year mod 4. It's just a little bit different way of representing that. And I don't think we need these parentheses. Okay, so if we are in the second month of a leap year, then we're going to say day plus equals 29. 29 days in February in a leap year. Otherwise, we'll say day plus equals, let's see, what did I call it? Days in month. Days in month of the current month. And now you'll notice we added a number that was larger than 7. And so we, in order to find out what the current day of the week is, once we've advanced to the following month, we need to do day mod equals 7. We'll just say 7 days in a week. Okay, and then at the end here, we should just be able to print out count equals %u. Okay, that gives us an answer of 171. So let's go back to the archive here. And you'll see that that is indeed our answer. So that will wrap up this video, and in the next video we will continue with problem number 20.